Hello and welcome to the third part of this cluster session. I'm Eva and I want to show you today the various possibilities of interface our UI+ cameras. Heiko has already shown you in the session before how the principle of vision-compliant cameras makes it convenient to use them either with machine vision software, but also for programming with our IDS-Peak SDK. This is what I want to show you today. I want to give you an overview about the possibility of interfacing UI+ cameras and also show you how to get started, because this is what you might be wondering about, how to get started. So afterwards, you will be able to start right off with your new UI+ camera and work with it in the way that fits your application best. Let's have a look at that graphic on the right side, from the bottom to the top. Our UI+ cameras, all of our UI+ cameras are compatible with the IDS-Peak API. So that means the USB 3 and GigiVision compliant cameras we offer. For those, we provide a respective firmware that is compatible with the vision standard and also the respective transport layer. You can see that the IDS-Peak API is based on the GeniCam API, which is the API that already comes with, but the IDS-Peak API is a convenience layer for the user. So for the user, it is much easier to work with the cameras than when using the GeniCam API. We will see that in an example later on. To complete the package, there's also the IDS-Peak IPL, which means Imaging Processing Library, which provides basic imaging processing functions you can use without having to include another library for image processing. And to complete the package, there are several programming samples, tools, and of course our well-known cockpit, which Patrick already showed to you, and with you can evaluate and test the cameras. The principle of vision-compliant cameras is that they carry all their properties and features with it. So you can use them right away in applications like Helken or LabVIEW, because these softwares provide a vision interface and you can access these cameras directly. There's also much more software like that on the market, but let's take Helken and LabVIEW as an example. When using Helken, there's the image acquisition assistant you can use to open and find cameras and to start the image acquisition. When opening the image acquisition assistant, you first have to choose a source. That means a transport layer with which you want to use the camera. As you can see, there are several in the list. The GeniCam TL, for example, is the transport layer provided by IDS. It appears in this list if you have IDS-Peak installed in parallel. The GigiVision 2 interface is the interface provided by Helken, and Helken also provides a specific interface for USB 3 cameras in addition. If you're interested in when to use which interface and what are the advantages, please take a look at Arne's session. He already made a session for our Vision channel a while ago, and explain in detail how you can use UI+ cameras with Helken and with the several interfaces. Once you have chosen an interface, you can connect to the camera. And once you're connected, you also have access to the parameters, and you can adjust them, like exposure time or setting a frame rate or area of interest. When you're happy with the parameters, you can start the image acquisition, either via Snap or via Live. So Snap would be a single image acquisition, and Live, of course, would be the live mode. With Helken, then you also have the possibility to do code generation. That means that all the stuff you have done before, like choosing your interface, doing the connection, starting an image acquisition, gets inserted as code in your script, and you can continue with your image processing. How does that look like with LabVIEW? LabVIEW provides a so-called Measurement Automation Explorer. That is a tool where you can also easily open UI+ cameras On the left side, you can see that there's a camera list with all connected cameras. In that case, one GigiVision camera is connected. And by double-clicking that camera, you can also access the features and do parameter settings. And afterwards, of course, you can also choose between snap or grab. If you do your own application in LabVIEW, LabVIEW itself provides a variety of samples that show how to use vision-compliant cameras in your own program. So you can use that to start off. We have now seen how to use UI Plus cameras with machine vision software. But how does that look like when using the IDS-Peak API? Because machine vision software often is quite expensive and not every application needs advanced image processing. So you also might want to use the advantages of IDS-Peak, because here you have a full software support. So every component comes from IDS. We provide the firmware with regular firmware updates, the transport layer, and also the API. So the Peak software is specially made for IDS cameras, tested and maintained. There are custom features you can use with the IDS-Peak API, and also convenience functions that make your life easier when working with the cameras. As I've mentioned before, you have the cockpit as evaluation and demo tool, so you can easily configure your cameras for the needs of your application. And you can also save user sets via the Vision Cockpit and use them later in your application. In addition, you have the IDS-Peak imaging processing library for basic image processing functions, like if you want to do something like mirroring or deburring or other basic image processing. Of course, when you have the need to do advanced image processing, you can, in addition, use machine vision software like Helken or LabVIEW, or use both in combination. It always depends on the needs of your application, which fits you the best. Now we have seen how you can use UI Plus cameras with machine vision software with the IDS-Peak API, but you still might wonder, why not use the GeniCam API directly? Because that is the API that comes with the GeniCam standard. Let's have a look at these two code snippets. The one here is GeniCam, and the one here is IDS-Peak. And they're just doing the same thing. They're starting the image acquisition. But as you can see, with IDS-Peak, there is very little code to use. So you have just 2 lines to start the image acquisition, and with GeniCam, you have to do much more. And you can also see that it is very easy to read the IDS-Peak code. It is very comprehensive, while with GeniCam, you have to know exactly, for example, which register you have addressed, and much more. So with IDS-Peak, you have an easy start with the IDS cameras, even if you're not familiar with cameras yet. The IDS-Peak API currently is available for C++, C#, and Python. Here you see some examples, some code lines for querying the exposure time, and you can see that the syntax of the programming languages is quite similar. This is nice because it makes porting easy. For example, if you have done your rapid prototyping with Python and now want to port your application to C++ because you want to use this performance, for example. Furthermore, there are code samples in all 3 programming languages, which also address common use cases, like, for example, showing a live image or loading user sets or parameter files, doing triggered image acquisition, showing how to realize a line scan application, how to query chunks, and much more. Another advantage is that the samples are based on CMake. What is CMake? CMake is an open source tool to build applications for different platforms. For example, you have installed Peak on your Windows PC and you use the C++ sample and you modify it for your application, for example, then you can use CMake to build your application for Linux without having to change a line of code. How can you do that? You can use the CMake GUI. CMake GUI is a very simple tool to use. Let's say you want to application that you have used for Windows, you now want to compile for Linux. Then you choose a generator, which you want to do that. For example, if you have Visual Studio installed, you can use that generator. Then you choose for which platform you want to build your project. And then you just have to say where your source code is located and where you want to build the binaries. After that, you just have to click Configure and Generate, and your project lies in a specified folder, and you can use it on the platform you have built it for. Now we have seen a lot about the theory about using IDS-Peak. Let's do a demo now. For that, I would like to use Python, and I would like to show you how easy it is to create a first program and get an image from the camera. And also how you can realize to adjust camera parameters. Of course, get an image from the camera, which is the most important part. And also display it. In this case, we want to use OpenCV. Of course, there are many more ways to display images. But for Python, it's a very convenient way to display images. And last but not least, save the image to the disk. When starting with programming, it is very useful to use the IDS-Peak manual, because in this manual, all the functions are described, and there are also code snippets for every function you can use. All right. For our demo, we want to use Visual Studio. Of course, for Python programming, there are also environments like Jupyter Notebooks or PyCharm, so you can choose the environment that you like the most. Here in Visual Studio, we of course need to include the IDS-Peak API and the IDS-Peak IPL. We also include OpenCV because we want to display the image with it, and we have to include NumPy, because to display the image with OpenCV, we have to transfer the IPL image into a NumPy array. All right. To use the IDS-Peak library, we first have to initialize it. Afterwards, we can create a device manager object, because the device manager gives you an overview of all available devices and helps you finding the device you would like to open. After updating the device manager, and of course, asking if there's even a device to find. In this case, I have connected a color camera, a GigaVision color camera, to the PC, so we can have an image later. You could query a camera list from the camera, but in this case, we just want to open the first available device, because I know that there's only one camera connected at the moment. Once the camera is open, we can access the node map of the device. That means the list of all available features and parameters. And after we've done that, of course, if you want, we can print some information about the camera model, for example, the model name. And now that the camera is open, we might want to load some parameters before we start the image acquisition. For example, let's imagine we have created a parameter file with a Vision Cockpit. We have saved it to the disk, and now we want to load it into our program. But if you don't know how to do that, we can have a look into the manual. On this manual page, you can see that for loading and saving camera settings from or into a file, there are code snippets in all 3 programming languages available. So you can just look up, okay, how would I load this parameter file, and just insert your code snippet. I already have prepared this snippet before, so you then don't have to watch me typing this. So here I have created a file name. In this case, I have located my parameter file directly next to my Python file, so I don't have to give an explicit path here. And with this function call, I can just load the file. Of course, there's also the option to only load specific parameters, like the exposure time. If I don't know how to find the parameters, how to find the setting for the exposure time, I can go back to the manual again. If you're not familiar with the content page here, you can also search easily via the search button. And for example, type exposure time. And you will see various results. The first one already looks very good. You can see for querying the exposure time or setting the exposure time, there are many code snippets you can use here. So luckily, I already have evaluated a good value before. So I can just insert that code snippet and keep on going. After all the settings are done, we need to open a data stream, because via the data stream, the image data gets delivered. And of course, to get the images to our PC, once the images are there, we need to store them somewhere, and therefore we need buffers. The IDS-Peak API gives you some help to find the right number of buffers and also the right size of the buffers. You can here see that you can query the payload size via the API. So how big a buffer must be. That depends on the pixel format, for example, or if you send chunks together with the image. And afterwards, you can also ask how many buffers are required as minimum and take that number. Here I have added a +1 because, of course, you can also add more buffers. After these numbers are clear, you can allocate these buffers and then finally start the acquisition on the camera. Now the images are coming in and we wait for a finished buffer, which means for an image. With the IPL, you can create an IPL image out of that buffer. As you can see, you also need the pixel format and the size of the image for it. And I have mentioned before that I have a color camera connected, and per default, a color camera sends its data in RAW format. So I need to debyer my image, which can also be done by the IDS-Peak IPL. In this case, we convert it to an RGB image, or in this case, BGR8, 8-bit image. Now that we have that image, we want to save it to the disk. There's also a function in the IDS-Peak IPL with which you can easily do that. Let's say we want to save it as a PNG file. Then we just can use that one code line. And I also did not specify a path here, so the image gets saved right next to my Python script. And last but not least, we want to see our image, so we have to display it. I mentioned before that to use it with OpenCV, we have to copy the IPL image into a NumPy array. This can be done with this function call. And now we have copied this image into an array. So we can say, okay, we don't need the image buffer again anymore. We don't have to block that buffer. We can free that buffer and queue it again for other incoming images. So I still have not displayed the images. This can be done via the OpenCV imshow call. and we include the wait key, so the program stops until we close the window again. Okay, let's check if that worked. Program is opening. You can see that the model name is displayed. In the background, the camera settings are loaded, so this is the reason why that takes a moment. All right, that worked out. So let's close the program and go back to the slides, because there's one more thing I want to show to you. With the next version of IDS-Peak, we will introduce a C API, which will complement the existing C++, C#, and Python API. So for this API, we've made a quite new concept. The concept is to be even more comprehensive. That means more user-oriented function names, easy to use, and still flexible. So flexible means that still the generic access to the function stays guaranteed. How did we realize this API? Well, there will be convenience functions for the most frequent tasks, like, for example, opening the first available camera. Also, there will be modules to configure features you need very often, like, for example, trigger modules. And there will be feature functions to access the main camera features. How will that look like? I can give you a short outlook. Here you can see an example in C, which is written in a very generic way. The camera list gets queried and allocated, and after some lines of code, the first available camera is opened. With the convenience functions of the new C API, all that would look like that. You just have one function call, peak camera open first available. These convenience functions will make it even more easy to use the IDS-Peak API, and even more fun. So I hope I could give you a good overview over the possibilities of the IDS-Peak API and the possibilities to use the camera with machine vision software. And I hope that I have made you curious for the next Peak version to come. So if you have any questions now, feel free to ask, and thank you for listening.